Okay, let's look at an equation we should all be very familiar with, which is speed equals distance divided by time. Now that equation will work out the speed, which tells us how far an object travels per second, really. However, both speed and distance are scalars, so that equation will not tell us anything about direction. However, we can write a very similar equation by replacing the scalars with their vector counterparts. So speed is a scalar, but the vector version of speed is velocity. And that equals not distance, but the vector version of distance, which is displacement. Now be careful, because we use small letter or lowercase s to represent displacement, and just divide it by time. The equation does very similar things. However, velocities can be negative. So if an object is moving backwards, we would end up with a negative velocity. So this here is a velocity. However, it will either be an average velocity for the entire journey, or else if an object's traveling at a constant velocity for a particular time or displacement, it can work out that as well. So very important, if an object's accelerating, this will not give you the velocity at the start or at the end. It will give you the average velocity for the entire journey. Remember, small lowercase a is our displacement, and this is just the time for our journey. Now, most of the time we use this equation, our displacement is going to be in meters. Our time here, the time taken for the entire journey, is going to be in seconds, which means our velocity will be in meters per second. So it has the same unit as speed. There's just a little bit more information contained in it because we're using the vector versions here.